This is the video for homework for Monday, October 15th, based upon the 4.5 practice on direct and inverse variations. Question number 1 asks you to describe the equation below as direct variation, inverse variation, or neither. So if we remember that a direct variation has to be y equals a number times x, and inverse variation has to be y equals a number divided by x. And if it's not either one of those, like if it's y equals mx plus b or some other type of function, then it would be neither. So this particular equation is not already solved for y yet, so to do so, we simply need to divide by the coefficient on both sides. So y equals x over 9, which means the same thing as y equals 19 times x. Those are both the correct version of the equation. So from here we can see it's being multiplied by x, so it is a direct variation. And that is because it is being multiplied by x. So as the x increases, the y does the same. It increases or decreases by the same amount. And for this particular example, the constant of variation is 1/9. So question number 2 said to create a graph that models an inverse variation. I did specifically ask you to choose an actual inverse variation equation. You could use one that we already used. You can make up a totally new one. I just did not want you to randomly sketch a graph that was completely inaccurate. So if you use the example that we use in class, you could have done y equals a divided by x. You could have used a totally different one, y equals 10 divided by x. You could have made up anything as long as it was y equals a number divided by x, substituted in x values to get the y values, and sketched a graph. So because it's an inverse variation, it should have been going in the shape of a hyperbola, and it should have had a vertical and horizontal asymptote, which means it will never touch the x or y axis. So if I were to use, for example, if I used y equals 10 over x, and I wanted to get some values, I would need to potentially choose values that 10 is evenly divisible by, so that I come out with some clean, even points. So I could start with 1, 2, 5, and 10. So when I plug those in, y is 10, 5, 2, and 1. But I also need some negative values, so I could do these same values in the negative form, negative 1, negative 2, negative 5, negative 10, and I would just get the negative version of the output, negative 10, negative 5, negative 2, negative 1. I would plot the ordered pairs, so we've got 1, 10, 2, 5, 5, 2, and 10, 1. And so you would just do your best to make it look like it's getting infinitely closer to the x and y axis, but never actually touching. Put your arrows on the ends. And then you graph your negative versions of the points. So negative 1, negative 10, negative 5, negative 2, negative 5, negative 5, negative 2, and negative 10, negative 1. And again, do your best to make it look like it's getting closer and closer to the axis, but never actually touching. And put your arrows on the end. And we did briefly mention how this is really like a reflection over itself across the line y equals negative x. Next question, you were to determine if it was a direct or inverse variation. If it was not already solved for y, that would be helpful to do so. If it was a scenario, it might be helpful to write a function or equation to model that scenario. So our first one, y equals negative 8x, is already solved for y, and it's just being multiplied by x with a y-intercept of 0, so it is a direct variation. Planet X Fitness charges $50 per yoga classes attended, so y equals 50 times x, where x would be the number of classes attended, y would be the total cost, so this is also a direct variation. On the third one down, to solve for y, I would divide by 8, so y equals x over 8, or y equals 1/8 times x. So because I'm not dividing by x, this is a direct variation. On the fourth one down, to solve for y, I would have to divide by x, so y equals 20 over x would be an inverse variation. The next one down, to solve for y, I would have to multiply by x to get it out of the denominator, so the equation would be y equals 120 times x, so that's a direct variation. The next one down, to solve for y, I first would have to get it out of the denominator, so I'd have to multiply by it. If I multiplied by x, that would not cancel anything, it would just give me x squared. So I have x equals 45y. To finish solving for y, I would divide both sides by 45. And so y equals x over 45, which is a direct variation. And the last one is already solved for y. X is in the denominator, so this must be an inverse variation. Which of the following represent inverse variation? Select all that apply. So we're looking for equations that when solved for y are being divided by x. So the first one is a direct variation. The second one, to solve for y, I'd have to divide by x on both sides, so this would be inverse. The third one, to solve for y, I would just divide by 6 on both sides, so that would be direct. The next one is already solved for y, so that would be inverse. And the last one's already solved for y, but it would be direct. The next question says, write an example of a real-world situation that can be modeled by a direct variation equation. Include the equation that models the situation in your answer. So this is very open-ended, but as long as your situation makes sense and it comes out to be a direct variation equation. So for example, if you're talking about visits to our monthly cost for gym membership, so it costs $35 a month for a membership at Planet Fitness. So if that's true, I can write an equation that models that scenario by saying the total cost can be found by 35 times the number of months. So that would be my scenario, that would be my equation, and because y is equal to a number times x and there is no starting cost, it's just 0, this would be a direct variation example. So the final question, does the situation below represent a direct or inverse variation? Justify your answer. Well, this is not a line going through the origin, so it's clearly not a direct variation. As these x values are increasing, these y values are decreasing, they're doing the opposite. I could really, if I absolutely had to be super accurate, I could do my best to pick out some ordered pairs and make sure they do have that relationship. But generally we can see from this that this is just half of the graph of an inverse variation, so it does represent an inverse variation. Because as the x's increase, the y's decrease, they do the opposite, and so it is inversely proportional.